So for now, split into the components level, okay. But instead of using the ESP idea, so I send the hello RS-485 on the ESP32 chip using the UART, basic UART debug. Then from the another end, which is the USB RS-485 specifier, is received the hello RS-485. So from here, I just open up the COM5 data term, basically is the ESP32 debug part. And for the COM7, which is the RS-485 terminal, basically, for output the data. So in this now, for this actually is more to an electronic component level, which I split into like a certain, because I only using the chip, 3.3 volt chip this time, not instead of using the ESP32 dev kit module. So I'm gonna show you here kind of quick overview of how all this component level electronic schematics works. So we have a ESPW-ROM32D, which is connected to CP2102, and which is the driver of the ESP32, basically to output UART from UART to USB into the laptop here. So it to display the debug and all the messages from here. So we have another end is MAX485 module itself, which is RS-485. Basically, it's a RS-485 to UART chip. So what it does here is basically we taking from the UART 2. What ESPW-ROM32 do offer is 3 types of UART. We have 3 of UART. So one we already use for the debug UART for the CP2102, and then another one we use for the RS-485. There's another one, but I think it's only, if you look at the data sheet, they only have the RX pin for that. So they have 3 UART for ESP32W-ROM32D. So now we connected to the MAX485 module here. So we take this UART part and we convert it into RS-485 communication. Then it passed through the pacifier USB, which is UART to RS-485 to UART, basically. RS-485 to USB. So what it does is it take the RS-485, convert it to USB, then it display on the laptop, which is terminal on the data term. Okay, I also created, which is the voltage regulator here. This is pre-made voltage regulator, which basically a linear voltage regulator. What it does is just convert 9 volt to 5 volt. There's a better regulator you can use. Actually, use the buck regulator, buck converter, and so on. That's much better actually. They have the involved with the inductor. There's better ampere for supply through the MAX485 chip. So what I power on here is this is battery, 9 volt battery going to the voltage regulator, 5 volt to the MAX485. MAX485 it doesn't work well on the 3.3 volt. That's why I power externally from the 9 volt converter. So here we can see that there's some advantage on the MAX485 chip. Basically, he has like it's a low power chip, so he able to handle, even though the current is quite low, because I just use the alkali battery instead the LiPo battery. This LiPo battery is much better in terms of the current supply. Okay, and this is not rechargeable as well. So there's a few things you actually can improve in this schematic. I actually have a design on. I already plan to design a PCB design for this project. Actually, it's going on also. And I'm able to display both, and means it works well. The schematic works well. So actually, they can improve more in terms of maybe using which is the buck converter or much better voltage regulator using the inductor type. And and that's kind of it. We're able to display the RS-485 data. That is good enough. So basically what it does is this whole PCB is he can convert the UART to RS-485 and also to display the data on it. We're also able to use maybe we can pass a Wi-Fi data to another ESP32 to get the data as well. So yeah, this is almost all involved in communication level. And yeah, that's it for now. This is what I can provide for you for the schematic and overview on this project. And that's good enough for this project. I think I have tried to work on other projects as well. Okay guys, that's it for now. This is more to electronic stuff. Thanks guys for watching. See you next time.